Okay, so it's me, Cameron Fridge. There's not a whole lot of room in this little room, but anyways, that's okay. So I'll be doing the circulatory system, and we'll be talking about just the arteries and the veins and just, the works. So here we go. The circulatory system circulates the blood and lymph throughout your body. It's consistent of a system of arteries and veins. Your arteries, they carry blood out of your heart, and they carry oxygenated blood that pumps out from your heart all throughout your body, and it goes from carrying oxygen and nutrients to your muscles and to your organs, making sure they're all alive and living and well, because blood is just how your body works. Without it, it just will not. And once all those nutrients are given and your blood is now deoxygenated, the veins will carry it back to the heart to pump, and that's what makes your quote-unquote circulatory system. That's why it's called the circulatory, because it's in a constant circular motion of pumping out of the heart and then pumping back into the heart. So all these three systems start working together and can deliver nutrients such as oxygen and glucose. I mentioned glucose specifically because that's going to come up at a later point that's really important. But like I said, goes back into the heart and just takes care of the body. Now, the circulatory system itself, the importance of it, it has three main functions. It transports your nutrients, it transports oxygen, and it removes waste. It protects your body, basically, with the use of white cells called leukocytes, which can perform defensive functions, which can help protect your body and save your body from foreign materials. There's also I'm really bad at pronunciation, but erythrocytes, which are just the red blood cells that carry oxygen. Those are what specifically carry oxygen throughout your body. And then there's the thrombocytes that actually aren't cells necessarily, but they're fragments of white blood cells. And these are actually very important because they help you with injuries when you have when you have blood loss, or when you have a just some kind of injury that creates a lot of blood loss. Thrombocytes are what come in and can help prevent that. They spread through the body and work off using the circulatory system, and they can help kind of plug or stop the bleeding and help you live. So just a little important thing just to remember. The reason I had these down is just these three things are very important. They're the kind of the main cells that flow through the circulatory system that does functions that specifically relate to the circulatory system. And just as a quick reminder, if it's the arteries, it's carrying it away from the heart, it's pumping it out, it's pumping it with oxygen. If it's the veins, it's pumping it back into the heart. So that's kind of the difference. Now talking about what would happen without the circulatory system, kind of the things that you would run into, some of the issues is, well, first, kind of obvious, is that blood would not get everywhere that it needs to go. Your blood flow would not be working as well as it could be with a circulatory system, with a constant pumping and circulation running everywhere. So if you didn't have this, you would not have the proper blood flow that you need for your muscles and organs, and they would not receive all the oxygen and nutrients that it needs. Without this right nutrients, kind of like what I talked about with glucose, I mentioned that earlier because glucose is a specific type of nutrient that converts your food into energy, and if you don't have energy, then your muscles and your organs can't work, and they would ultimately start killing off all the cells, eventually killing off major and vital organs. So it's very important because without the circulatory system, there is no transportation mode, there's no transportation method for all this blood getting around, keeping your body healthy and living and alive. Now there's also some mutations in the circulatory system. First I want to talk about some benefits that come from it, some kind of weird things that have been recently founded. So there is a new mutation that was recently discovered called ANGPTL4. They don't have an actual name for it, that was just the name that was in the article I read. And this comes from this mutation has an effect for some reason, can lower the levels of triglycerides, which is a long word, and I'll kind of explain that better. Triglycerides, that's what it is. Triglycerides is a specific fat in the blood that has been linked to many heart diseases and even heart attacks. That's which is a big no-no because you need that to live. So the ANGPTL4 mutation, for some reason, has been able to prevent lipoprotein lapses, LPL enzyme, the lipoprotein lipase, it's a weird word, enzyme, LPL enzyme is what they called it. It prevents that from being created, and when that's created, it breaks down triglycerides from working. So if that can't work and that's not in your blood, if triglycerides cannot form in your body, then you can't have, that increased fat in your blood and that increased chance of having a heart attack. So they did research over patients that had this disease, had this mutation in their blood, and they had a lower risk of heart diseases and heart attacks than the other patients did. So just kind of interesting to see that a weird mutation that can actually help you, that they don't know how people have gotten it or what the mutation itself is, but it is interesting to see that there is an actual change of a mutation that can actually help. So there are some, but there are lots of mutations in the circulatory system that are an issue to the body. There's a lot of them that I really couldn't get into, but all of them come down to two different effects that they have on your body. One, they can affect your heart contractions, meaning that your heart cannot pump properly and that it will not pump in the way that it needs to be, and it won't get the blood circulating throughout your body in the time that it needs to, because there is a specific speed to how much blood circulates around your body, and there's mutations that can affect that. There's also mutations that can affect the rhythm of your heartbeat, which they can, if you've ever heard of someone, their heart can skip a beat or skip a heartbeat, that's really dangerous and can really mess up the whole system, because really the system is very perfect and is very precise. So if it gets messed up, then your whole body can start to shut down. Now I want to talk about kind of where we learned all this information. This is from a scientist and physician, William Harvey. He was the first one recognized to give a real and accurate description of what the circular system was like. As you can see here, I don't know how clear it is in the video, but there's moments where he would, to show people, just to give a demonstration, he would tie a rope around the arm and tightly, and you can start seeing veins. It's kind of like what doctors do now when they try to give blood and make the veins pop. That's how he would first show people, but that was much later on in his research. What was really interesting is that he was the first one to find out that the heart is the reason for circulatory system, for the circulation in your body. People believe that at his time, believed that the lungs were the reason for this, but he did experiments and tests on animals to see how their blood moved and how their blood pumped throughout the body, and he noticed that it was through these, he described them as muscular contractions, meaning that through, there was some organ that was constantly pumping this blood, which he further concluded that it was the heart that was doing this. So because it had to be, he started also noticing these, he called them tubes that would go throughout the body, and he started noticing that as much blood that the heart is pumping out from the heart, that's way too much for the tissue to absorb, way too much for it to take in. So he said there must be some kind of way that it can disperse it across the whole body evenly without hurting the body, without disrupting it. He wrote a whole book called De Motu Cordis, I'm probably pronouncing that wrong, where he stated his final hypothesis for the blood circulation. He said that these relatively large vessels were in He knows how large these vessels are, and that it transmits so much blood around the system that it couldn't just be blood just going everywhere immediately, that there has to be some kind of system to it. So this is actually a quote from him that I'm quoting. It says, "I began privately to think that it might rather have a certain movement, as it were, in a circle." He was starting to believe that not only were there vessels going all throughout your body that would connect this blood, that would circulate this blood, but that it all went in one motion, that it all circulated into one system. That because he started to think that you can only have so much blood, and that there has to be some kind of motion for it to come back. He said that the amount of blood that was produced in the body was too big to be supplied by just the food that we ate, and also as much nutrients as we're getting from our blood is way too much. So he said there's way too much blood in our system to just be from our food, from our nutrients, and he deduced that it's all the same. It's all coming from one, filling of blood that is constantly stirring within our body, that's constantly circulating within our body. So very, very important, very intellectual, really knew what he was doing, and even has stated multiple times that this was a very intriguing system, and that the system was perfect, and that it clearly has a very mature way that it settles. He even says at a point in his book about how nature is not chaotic, that there is reasoning to it, that there is purpose to it. So that's really what helped him in his studies, to think that, well, it can't be that the blood just does this for some reason. There has to be some kind of motion for it to come back around. So finally is when he concluded what we know now, that the blood in our body moves in this continuous circle by the action of our heart constantly beating. This isn't super important, but just interesting about his life. He actually died at the age of 79 due to a intracerebral hemorrhage, which is a condition caused by the rupture in the circulatory system, and that is, we know that because of his work, because of the studies that he did, and what we understand now about the circulatory system. So pretty interesting. So now concluding with the future technologies, the future things that we have now, what we're working on currently. There's a study by John Rogers and his team at the University of Illinois, where they've created what they call the sock for the heart, which this is a small sleeve basically that fits over the surface of the heart, and it basically helps it in every way it can. It has sensors that connect to monitors that can identify irregular heartbeats to notify professional authorities. So say if someone has a heart attack or someone's heart skips a beat, it will notice that irregular heartbeat, and it'll notify the authorities to say, like, hey, this person's heartbeat isn't what it's supposed to be. It has these, it can detect and pinpoint where these irregularities are, and can send an electric shock to that point, and basically shock your heart back into a normal rhythm, so that you can, continue to go. The really cool thing too is that it also, it's also kind of the replacement of pacemakers, because one, they're much more clunky or bigger than this sock that they've created, and so over time you have to get those replaced, because it's just too much to keep in your body at a time. But with this, they say that they could keep it in the body forever, and that it could stay that you could stay on your heart for as long as you need it to. Now there's testing going on right now to see for the long run, to see how long it can really last staying inside your body, how long it can be powered, how long it can be sustained, and even saying that in the next few years this will be available, I guess, on the market. I don't know what the actual place would be, but yeah, it's really cool. It's very interesting, and it's really cool just how it keeps the heart in shape, keeps the heart protected, keeps it all together, and so yeah, that's the end.